Hello, welcome to my YouTube channel. Today is the next video on mathematical formulation of quantum mechanics. Today I am going to tell you about a different kind of vector. Before going into that, suppose I have a number 5. Okay. Suppose I have a number 5 which is a function of a ket vector A. So 5 is a function of ket vector A. Okay. Now I am going to tell you about the two properties of this number 5. One is that phi is linear. Now what does it mean? Phi is linear tells that if phi1 is a function of A1 and phi2 is a function of A2 and phi3 is the function of A1 plus A2. Then the linearity of this number 5 tells that phi3 equals phi1 plus phi2. Okay. So as phi is linear, this equation holds. Okay. So this is the number one properties. Now next property of this number 5 is that suppose phi1 is a function of A1, okay, and phi2 is a number of a function. Phi2 is a function of C1 times A1, okay. Then phi2 will be C into phi1, okay. So this is second property of this number 5. Now I have told about two property of phi. One is this and the first one was linearity. So these two properties tells that phi is something like scalar product. We have known about scalar product in vector algebra. Why is that? Scalar product also is linear. Scalar product also holds this property. So phi is like a scalar product. Now to have a scalar product, we need two vectors. So phi is a scalar product of this A vector with a new different kind of vector. We will define what that vector is. So phi is what? Phi is scalar product of a ket vector with a different kind of new vector. This new vector is called as bra vector or simply bra. Okay. So phi is scalar product of ket vector and a new vector which is called bra. This bra vector is denoted as this, just opposite to this. Ket vector is denoted as this and bra vector is denoted as this. Now what? A is a ket vector and suppose B is a bra vector. Then phi is scalar product of this and this, and the scalar product of this number phi is denoted as this. So this is like scalar product, and this is called bracket. This denotation, this is bracket. And this bracket expressed what? This bracket expressed the scalar product between bra and a ket. Bra comes from this first three letters, bra. This one is bra, the first one, and the ket is last three letters, ket. I don't know what happened to the letter C. Okay, so this is scalar product and is denoted by this, and this is bracket. First letter is bra, is a vector, and ket is a vector. Now I have told about this new vector. Now a bra vector is only defined when we define the scalar product of this bra vector with every possible ket vectors. Okay, so let me write it down. Suppose I have a bra vector. This is a bra vector, and this is defined only when we define all the possible scalar products. Like this is scalar product of this bra vector with a new ket vector for every ket vector. If I define scalar product of this bra vector with every possible ket vectors, we define this bra vector. Okay. Now this bra vector is equals 0 only when this bra vector is 0 only when this scalar product is 0 for every a ket. So a bra vector is 0 only when scalar product of this vector with every possible ket vectors becomes 0. Only when this bra vector is 0. Now I have told about the property of this bra vector. I have introduced bra vector. Now what is the connection? What is the connection between a ket vector and a bra vector? Now, the only connection that I have told out this is that a bra vector when scalar product with a ket vector gives a number 5. This is the only connection that I have told. Now there is a deep connection between them. So what are the connections? Okay. Now we will make two assumptions. First one is that a ket vector and a bra vector has one-to-one correspondence. If you have read about linear algebra, you have obviously known about one-to-one correspondence. Okay, if you have read about set theory, so a ket vector and a bra vector has one-to-one What does this mean, one-to-one correspondence? Suppose I have a ket vector A1 and I have another ket vector A2. Okay. And the bra vector corresponding to this ket vector I suppose is B1. Okay. And the bra vector corresponding to this ket vector is B2. Okay, and the bra vector corresponds to this ket vector. The bra vector corresponding to this ket vector A1 plus A2 is nothing but this addition of these two. Okay, so if I have a ket vector A and A2 and the bra vectors corresponding to these two ket vectors are B1 and B2, okay, then the bra vector corresponding to A1 plus A2 will be addition of these two bra vectors. Okay, this is one-to-one correspondence. Now next assumption is that suppose I have a ket vector A, okay, and the bra vector corresponding to this ket vector suppose is B, okay, and I multiply a complex number C with this ket vector. So C1A has a bra vector which is suppose B dash. So A has a bra vector B and CA has a bra vector B dash. So we assume that bra vector B dash will be C star B. C is our assumption. Okay. So what is C star? C star is a complex conjugate of C. C is a complex number. So this is complex conjugate to this complex number. So this is our assumption. And from this assumption, I demand that a bra vector is a complex conjugate to a ket vector. Okay, so I demand, what I demand? I demand that bra is a complex conjugate of a ket vector. This is complex conjugate of ket vector and this is bra. So bra is a complex conjugate of ket vector. Why is that? Okay, suppose I have a number complex number ix, okay, and the complex conjugate of this ix is minus ix, and if I multiply this with a number c, suppose a complex number cix, then its complex conjugate becomes what? C star minus ix. Okay, so when I multiply the complex number with a complex number c, its complex conjugate becomes c star multiplied the previous complex conjugate. So this is same thing as I told about the second assumption of bra vector. A bra vector B, which is corresponding to a ket vector A, and if I multiply this ket vector with a complex number A, then this becomes C star B. See, these two are same thing. This A is this, suppose, and this is suppose this. So when I multiply this with a complex number C, this becomes C star into this. Similarly, this becomes C star into this. So B vector is nothing but the complex conjugate of this vector, as this is complex conjugate of this. Okay, so bra vector is always a complex conjugate to a ket vector. Okay, this is the connection between a ket vector and bra vector. These two are complex conjugate to each other. Okay. Now, I have told you about that bra vector and ket vector is a complex conjugate to each other. Now, you may think that bra vector and the ket vector is like complex number. But they are complex number, obviously. But they are not like ordinary one. They are not ordinary complex vector, complex number. Why is that? Suppose I have a complex number z. Now we can divide this complex number in two parts. Okay, one is real part and next is imaginary part. So if I have a complex number, we can divide the complex number into two things. One is real and second is imaginary number. And if I have suppose I have a ket vector A, which is like complex number. If I try to find its real part and its imaginary part, can we find that? Now, how do I get real part? The object. The real part real part of Z is Z plus Z star by 2. This is the real part of Z. Z star is the complex conjugate of Z. So real part of Z is Z plus Z star by 2. If I try to find the real part of this kth vector, what will be the formula? The real vector of A will be equal to A plus A star. Now what is A star? A complex conjugate of kth vector is bra vector. So this is a bra vector. So I am trying to find the real part of a bra vector. Okay. So the real part of a bra vector is bra vector plus the complex conjugate of bra vector by 2. Similar like this. Now what is the complex conjugate of bra vector? Complex conjugate of bra vector is kth vector. Okay. So the A plus, now this is bra vector and this is kth vector. Now we cannot add a bra vector with a kth vector because bra vector and kth vector are of different nature. These are not same kind of vectors. We only add or subtract same kind of things. Okay. So A vector, which is a bra vector, and this one is a kth vector. We cannot just add them. A bra vector or a kth vector cannot be added together. Bra vector can be added to a bra vector. Kth vector can be added to a kth vector, but a bra vector and a kth vector cannot be added or subtracted. So to find the real part of this bra vector, we have to do this, and we cannot do this. So a real part or imaginary part of bra vector or a kth vector cannot be found. These two parts, real part, imaginary part of a kth vector or a bra vector, do not exist. Okay, so a kth vector or a bra vector is like complex numbers, but they are not ordinary ones because we cannot find the real part and imaginary part. So these are not ordinary complex numbers. Now you may find it strange because the reason is that what we are trying to do here, we are trying to formulate mathematical entities. Okay, we are trying to find mathematical formulation of quantum mechanics. Now these are all the formulation of quantum mechanics. Now you cannot just experience quantum mechanics in daily life. We experience complex numbers in daily life, in classical mechanics, electrodynamics. Okay, but we will never experience quantum mechanics in daily life. We cannot think in a classical manner and find the quantum mechanics in our daily life. We cannot do that. That is why we cannot find A, which is a kth vector, or a bra vector in our daily life. So this is a kth vector. We cannot do that just because this represents all quantum mechanical things. So bra and a kth vector are like complex number, but they are not ordinary ones. They are different kind of complex number. Okay, because we cannot find the real part and imaginary part of a bra vector. Okay, now we have told about bra vector and kth vector and some properties of the bra vector and kth vectors. Now there is one more assumption that I am going to do, which is that suppose I have this is a scalar product between A, which is a bra, and the B, which is a k. This is a scalar product between bra vector and k vector. Okay. If I change the order, if B comes here and A comes here, like this, what will it become? It will become the complex conjugate. So if I change the order, we have to complex conjugate of this. So this is a complex conjugate of this one. Okay, this is another assumption. Okay, now we have a k vector which represents state. Okay, so state of the system represents a k vector, or is represented by a k vector. State of the system is represented by a k vector, and a k vector has a bra vector which is complex conjugate of that k vector. So a k vector has a bra So a state can also be represented by a bra vector. Okay. So state of the system cannot only be represented by ket vector, it can also be represented by a bra vector. Okay, so if I have a bra vector A, okay, and its ket vector, which is these two represent same state. So state can be represented by either a ket or a bra. Okay. Now I am going to tell you about two definitions. One is orthogonality. What is orthogonality? Suppose you have read about orthogonality in linear algebra. Suppose I have two vectors, suppose A and B. Okay, so I have a ket vector A and a ket vector B. Now these two will be orthogonal to each other when the scalar product between these two will be 0. When this is the case, scalar product between these two vectors is 0, then these two vectors are orthogonal to each other. This is orthogonality. Okay. So this is definition of orthogonality. Now, second definition is length or norm of a vector. Length or norm of a vector is defined by this is the length or norm of a vector A or B. Okay, so this is length or norm. This is the definition of length or norm. Okay, so in this video and the previous video, I have told about many mathematical things, many mathematical entities, mathematical equations, mathematical assumptions. Now, these all seems to be mathematical only. Okay, but these all mathematical equations, mathematical things, mathematical entities, mathematical assumptions, all of these has a deep physical meaning. These all mathematical equations that we are setting, okay, will tell about how the result of observation will be. Okay, so these mathematical things that I have discussed in the last two videos are not just mathematical. These all has a deep physical meaning, which is quantum mechanical meaning, Okay, so we will talk about that later, how the physical sense of these mathematical entities comes into the picture. Okay, so I have told about the mathematical formulation of the state of the system. Now one more thing is due, which is dynamical part. Okay, the variables, the observables like force, like momentum, like energy. These are observational. These are variables. Okay. So we have to we should have a mathematical formulation of those physical qualities. So in the next video, I'm going to tell about those physical observables and their mathematical entities or mathematical formulation. So this is in the end of the mathematical formulation of the state of the system in a quantum mechanics. Okay. So thank you.